Hi, welcome to the sixth video in our leaf tissue data series. Today we're looking at boron. We're going to look at leaf tissue misinterpretations and then look at a little deeper dive into what our data showed us about boron from our 2025 data set. So let's jump right into the leaf tissue. Just like we did for the other nutrients, you've got the leaf tissue concentration up the y-axis, and then across the x-axis is the boron pounds per acre of content in that crop. And you'll see here that you've got a lab sufficiency range from 5 ppm to 25 ppm at the stage that these were pulled. And we have most samples are within that lab sufficiency range. It'd come back as sufficient. You'll see a cluster up here, though, that as we get further to the right, they're finding themselves above that sufficiency range. The R squared in this case is strong because that trend line is going up to the right as we go across the crop content. So we do have good correlation of leaf tissue information and pounds per acre of content, but it still has the same misinterpretations associated with the data that we've had with the other nutrients. Because, for instance, here below 0.02 pounds per acre, you have a 10 part per million boron sample. And then you see all of those 10 part per million boron samples on this grid line as you move to the right, all the way up to 2.5, almost 3 times that 0.02. They all have the same concentration in a leaf, but they have dramatically different plant content. So how do you decipher that? Let's put the yield information up there. So when you look at what does this associate with in the way of boron content, here you're looking at 100-ish bushel corn. Up here, you're getting into 300 bushel corn. And you see the most of our dots are in 150 to 260 and a little higher. So you've got all these spread out all over the place. So if you're just going on leaf tissue concentration, the danger of that is that moving up doesn't help you. We think we have 5 part per million, we're low, and we have 25, we're high, but all the 5 and 25 on this grid line are all associated with like that 200-ish bushel corn range. So you don't really know where you are. When you get up into these higher numbers, here's 0.06. This is 300 bushel corn potential, at least on the boron curve, but you still have a very low leaf concentration. Where up here, you have about the same quantity, but you're up at like 37, 38 ppm of boron. So that higher number looks like it is, for the most part, if you're looking at 250 plus bushel corn and you get over 25 parts per million, that's a sign that you have all the boron you need. But if you get down here into this cluster, you can misinterpret an awful lot of that data. So most of the production corn, you don't know whether a 5 ppm is good or bad, all right, because we have plenty of examples of both being the case. So got to be careful when you're utilizing leaf tissue for boron. You don't necessarily know you've got the right answer. So what did our data look like this year? Just something quick on boron accumulation. You've got about 2/3 of it happening by tassel, and then you've got the remaining third happening during R stages. A boron will peak early before you get to maturity. It actually gets up above your maturity is where I have 100% set. So up here, you're seeing like 110% because there's a surge of boron right before you get to the milk line moving. So the other thing that I found odd is the published rate of boron that I found in several locations. It seemed like they were off a factor of 10 versus what reality is showing us. We look at thousands of samples, we look at what the boron content was associated with different yields across the country. And the average pounds per bushel was ranging with 0.0006 to 8, but published was like 0.003. So a big discrepancy in what people are telling you need for boron and what the crop is actually needing. To kind of put this in context, I was finding there's a certain popular fertilizer removal app out there that said you might need well over half a pound of boron for a 250 bushel corn crop. Well, in our data, we're finding 250, 275 bushel corn maxing out at about a quarter of a pound of boron when you get to this peak, and then dropping down to say 0.15 pounds of boron. So a big discrepancy in data versus what publications have been showing us for boron. So in our data set, we only had luxury levels of boron in about 16% of our samples, meaning 84% had some level of deficiency, but it wasn't high. So we broke that out and looked at what's the impact of that. And here you can see over here to the relative yields by boron level. If you didn't have sufficiency, you didn't have excess, I set that at 100% of yield potential. And you really only had about a 2% drop, maybe up to 3 on most of these conditions, meaning across thousands and thousands of samples, it only really made about a 5 or 6 bushel difference for boron content. I'd heard many people talk about double-digit responses to boron, and maybe that might be a specifically regional thing, but across the averages of the samples, we're simply not seeing that. The average deficiency of just the deficient samples in the Agrimodis system was 6/100ths of a pound, and that is just barely over 7 ounces of a 10% liquid boron. If I put all the samples in one pile, the average boron level versus goal, based on yield goals across the country, was just under 500. So about 5.5 ounces of 10% boron would be the fertilizer equivalent of that. All right, so maybe boron's not as big a deal as we thought it was. I know it has purpose. I know it's got physiological function. We shouldn't ignore it, but we shouldn't expect to have 20 bushel yield gains because we added boron to our program. All right, so that's it on boron. Thanks for your time today, and we'll see you in the next one.